Deep beneath our feet, the rocks whisper about events that should not be possible. Iridium, where it should be scarce. Microscopic spheres that look like industrial ash. Climate shifts that feel less like accidents and more like someone turned a dial. We like to believe we are the first to split the atom, to refine metals, to heat the sky and cool the seas. But what if Earth holds older chapters, pages scraped away by time, tectonics, and ice? The Silurian Hypothesis asks an unsettling question. If an industrial civilization had risen and fallen millions of years ago, would we even recognize its trace today? In this film, we place hard geological signals beside the oldest Mesopotamian traditions of the Anunnaki, those who, in the stories, came from the heavens, bringing knowledge, city building, and metallurgy. Myth, perhaps. Science, we will keep it disciplined. If myth and the deep archive rhyme, maybe the rhyme itself is a clue. Over the next 15 minutes, we will follow 3 threads: vanished technosignatures in stone, ice, and sediment, mass extinctions and evolutionary jumps that feel like resets, and Sumerian tablets Enki, the Apkallu sages, the king list that read like cultural memory of knowledge returned after catastrophe. If rock can hold signatures, let us read the first one, written in stone. We begin with what rock remembers, and how a single day can mark an age. In the late 1970s, geologist Walter Alvarez examined a thin clay seam in Italy at what scientists call the KP boundary, the line between the age of dinosaurs and what followed. He found iridium levels around 30 times higher than normal. One impact day, one mark in rock that remains obvious 65 million years later. If a single asteroid can leave a clear timestamp, what would an industrial civilization leave? We already know the outline of our layer. A sharp drop in the carbon isotope signature known as Delta 13C that betrays the release of very old carbon. Plastics and plastiglomerates pressed into beaches and sea floors. Radioactive byproducts from nuclear testing that future geologists will read like a date carved into stone. Now, step backward. Some older layers show motifs that feel familiar. Carbon swings like you would expect from massive combustion, high-temperature microspheres that resemble industrial fallout, greenhouse pulses that rise fast and fade slowly. The textbook says large volcanic provinces or methane blowouts. Often, that will be right, yet the scale and timing keep nudging the door open. Here, the Anunnaki tradition enters not as proof, but as a cultural echo of abrupt arrivals of technique, metallurgy, irrigation, calendars that appear in the human record as steps rather than drifts. If cultures can step, perhaps technosignatures can step too. If stone does not lie, why does the Book of Life seem to have so many missing pages? The fossil record reads like a novel with chapters torn out. The Cambrian explosion arrives like a jump cut. In a geological blink, eyes, shells, mobility, hunting. Preservation bias explains part of it. Soft bodies fossilize poorly. Yet several leaps and reset moments coincide with hard chemical turns, oxygen rising, carbon regimes flipping, nitrogen cycles rewiring, as if multiple sliders move together. Consider the Great Dying at the end of the Permian period. The carbon signal looks like planetary scale burning. The standard answer is the Siberian traps, unimaginably large volcanic outpourings. Still, the selectivity of loss and survival can seem strange. Whole lineages vanish while others skate through as if pre-tuned for what was coming. Sumerian lore remembers cycles of founding, disruption, and restart. The Apkallu wise figures bring arts and sciences before a world-ending flood. After the flood, knowledge returns in measured fragments. As metaphor, that maps neatly onto the geological pattern: long, quiet, sudden function. This does not prove intervention, but the recurring triad stability, shock, higher order, demands careful attention. If leaps in life track sharp chemical turns, then the air itself should have something to tell us. Ice and mud, remember. Tiny bubbles in ice cores preserve ancient air. Layered sediments stack year after year. Across several intervals, we see rapid pulses in carbon dioxide and methane, sharp rises with long, soft tails. Volcanoes can do this. So can giant methane releases. Yet some pulses look like sustained combustion or even deliberate climate management. Aerosol fingerprints, changes in scattering, and sequences that feel like policy cycles: on, off, on again. If a civilization ever managed the sky, what should we look for? Isotope blends that point to deeply ancient carbon sources, truly synthetic compounds that nature does not synthesize. Repeated, patterned sequences rather than one EOF spikes. Sumerian texts call their gods masters of wind and water. Poetry, yes, but in a river delta world, the ability to steer air and flow is literal power. The geological record includes intervals where the idea of air control is not far-fetched. The discipline remains the same. Interlock independent lines of evidence before claiming anything. Myth may point to where to look. It does not decide what you find. And if the sky was steered, what materials might betray the hand that steered it? To find a lost industry, we do not expect blueprints. We expect byproducts that endure. If plastic will be the emblem of our age in the rocks, what should we do with older strata that report grains behaving like tough synthetic polymers, astonishingly stable against decay? The safe call is contamination, and often that will be true. Still, a few remote cores have returned patterns that look designed rather than random. Add to this repeated reports of titanium-rich or steel-like microspheres in old layers consistent with very high temperature processes. Orthodox explanations include meteoric spherules, volcanic jets, and chemical overprints during burial. All are valid possibilities. But if a vanished industry left no machines, only residue, This is exactly the sort of footprint we should expect. Anunnaki lists weave metals, measurement, and cities into a single story. If old industry ever existed, our best chance is not artifacts on a shelf, but material crumbs in the archive of Earth. The rule stands. Try to falsify the non-natural route first. Yet, if multiple independent signals keep pointing toward industrial processes, dismissing them becomes its own bias. Traces of extreme heat lead naturally to the hottest clue of all nuclear timestamps. Around 2 billion years ago, the Apkallu uranium deposit in what is now Gabon ran as a set of natural nuclear reactors. That discovery teaches a crucial lesson. Nuclear signatures can persist and be read across deep time. In younger rocks, analysts sometimes report odd radionuclide blends ratios that hint at fission products, or at least unusual neutron histories. Standard replies point to geochemical mobility, cosmic inputs, or laboratory issues. Those must be checked first. But if a technological society ever experimented with fission and then failed, moved, or faded, we should expect exactly these shadows, concentrations, ratios, and coherent spatial patterns. A single odd reading is noise. Correlated clusters begin to speak. Sumerian cosmology includes images of heavenly weapons and mountain-melting fire. That is poetic language, but it aligns with the only technology we know that restructures rock at scale, nuclear and thermonuclear heat. It is not proof, only another rhyme between story and signal that urges us to keep testing. If delicate signals can survive for ages, where would a vault of evidence last the longest? In the quietest archive on Earth, Antarctica. In cold and stillness, patterns and molecules can outlast empires. Antarctica is a natural vault, cold, dry, and quiet. Radar surveys sometimes sketch suspiciously regular patterns beneath the ice. Deep sediments have yielded a handful of molecules that raise eyebrows. Caution comes first. Nature can draw straight lines and chemical surprises happen. Yet if you wanted to preserve a long-lived repository, you would hide it where erosion is minimal and life is sparse. Across many traditions, myths remember primeval cities swallowed by ice or sea. Sumerian sources speak of pre-deluge centers of learning, followed by a world rebuilt from archives. Antarctica is the perfect archive. Low oxygen, low biology, little disturbance. If truly hard artifacts survived exotic alloys, synthetic minerals, the best odds may be beneath kilometers of ice, shielded from weather and chance. And what the Earth forgets, the sky may remember in orbits and on airless worlds. Beyond erosion, orbit and regolith act as time capsules. High, quiet orbits and the Lagrange points can be stable across geologic ages. The lunar surface is an airless ledger. If an earlier civilization used orbital factories, asteroid mines, or solar collectors, we should expect objects with odd reflectance, unnatural albedo, or station keeping that only makes sense for an engineered plan. Anunnaki traditions are saturated with traffic between sky and ground. In modern terms, think space infrastructure as the backbone of a planetary economy. Without invoking visitors from elsewhere, we can still ask a clean question. Where would artificial objects survive for millions of years? The answer is quiet, deep orbits and airless bodies such as the Moon and selected asteroids. We already have tools, wide-field sky surveys and precision photometry. It is time to expand the search for extraterrestrial intelligence into a search for extraterrestrial Earth. Technosignatures here, both present and past. To speak across geologic ages, you must write in matter itself. Durable standards and encodings can outlive dynasties and even continents. If you want to communicate across geologic time, you must write in matter, crystal lattices, isotope ensembles, and megascale patterns. Mesopotamian texts speak of the ME, divine decrees that encode the protocols of civilization. Mythic language, yes, but conceptually modern. Standards durable enough to outlast regimes. So what should we test? Engineered periodicity inside crystals, structures too orderly for blind chemistry, isotope patterns modulated beyond natural baselines, landscape-scale geometries whose information density exceeds what wind and water can sculpt. It sounds exotic, but for messages meant to outlast tectonics and weather, lattice-level encoding is rational. Myth does not prove such messages exist. It aims the flashlight at plausible places to look. Matter may carry a message, but myth often preserves the map to find it. What do the Anunnaki tablets add? Not proof of visitors from the stars, but a map of motifs. First cities appear abruptly, bundled with metrology and metallurgy. The Apkallu deliver arts and sciences before a great flood. After, fragments are restored. The king list counts reigns before and after catastrophe, explicit cycles of order, break and rebuild. That is how technosignatures might behave in the rocks. Build, break, reassemble. Read the Anunnaki as cultural memory of knowledge transfer under duress. Then set it beside the geological record. Whenever Earth takes a major hit, impact, flood basalts, climate lurch, life sometimes reorganizes fast. Perhaps that is purely natural. Often it island, but sliding myth over pattern yields a search strategy, where tradition places jumps, test those strata for clusters of non-natural chemistry and materials. Yet maps are not proof. So what would evidence actually look like? If we mean to test this, we need crisp, falsifiable criteria. First, co-location. In one clearly dated package, find synthetic compounds, anomalous isotope ratios, and industrial-style microspheres together. Second, replication. The same signature must appear in independent cores across distant regions. Third, non-natural ratios. The patterns must fail to match volcanic and meteoritic reference libraries. Fourth, material impossibles. Alloys or structures that imply processes nature does not provide at that temperature and pressure. Fifth, a space crosslink, an Earth layer synchronized with residues found in orbit or on the Moon of matching composition. Only when clusters like these cohere does the balance of explanation shift from natural to cultural. At that point, the label Anunnaki or otherwise is secondary. First the signal, then the story. Now, why this matters? Suppose we are not the first. Then, Earth is a palimpsest written, scraped, and written again. The deep time lesson is sharp. Technology is not the finish line. Sustainability is the exam. Our own layer, carbon, plastics, radionuclides, is being written now. If earlier civilizations crashed on over-extraction, weapons, or climate over-austere, our mandate is clear. Break the cycle. Search better. Read myth as map. Act with restraint on powerful tools. And if rocks and stories converge, our next step is not belief, but responsibility. If the rocks and the stories are both right in their own ways, then we are not the first minds to stand at this crossroads. Deep time does not honor pride. It records only what we do. So here is our charge. Treat Earth like a library, not a quarry. Hunt coherent technosignatures with the same rigor we use to seek life beyond our sky. Fund the unglamorous work, deeper cores, cleaner labs, longer watches of the dark. Seat mythkeepers beside isotope chemists and planetary astronomers, and let each discipline correct the other's blind spots. Whatever we find or do not, choose a path that leaves a layer we are not ashamed to bequeath. One that says they learned, they broke the pattern, they built for endurance. If you can hear the whispers of the Anunnaki, leave a sign so the signal carries. Mark the layer with a like. Join the archive by subscribing and ringing the bell, and guide the next dig in the comments. Should we decode Enuma Elish, the Apkallu tales, or the King list next? When enough marks appear, the next chapter unlocks. Listen closely. The whispers are getting louder.